Hello, my name is Mary McCormick, and this is my senior capstone project, a project that I call PastGen. It is a password tester and generator. It is comprised of 5 files, 3 C++ code files, and 2 header files, which act as statements to tell you what will be contained in the C++ code files. The main method is executed from main.cpp and contains 2 phases based on the tester and the generator. When the code first executes, it outputs the string, "This is a password tester, please input password." Once you do, you enter the tester phase. The tester phase will take that password and judge it by a number of different criteria. The first being whether or not it contains anything in the common bank. The common bank is a series of short strings that, if your password contains these short strings, cause the password to automatically fail. There are other criteria that must be passed. Whether or not the password is too short or too long, it could fail. If it contains a common word or a common string, it could fail. Or if it fails the check repetition, which is a second method that judges the password's characters. Testing 1, if any of the characters repeat immediately, or 2, if any of the characters appear more than 3 times within the password. Either of these, will cause the password to fail. Should all of these check out and you have yourself what seems like a viable password, numbers will be assigned based on the frequency of the 4 content checkers, which check for capital letters, lowercase letters, numbers, and symbols. Each of these are given a weight based on their complexity or their commonality, with lowercase letters having the lowest weight and symbols having the highest weight. There's also a +1 here, because if you have gotten this far, you deserve to have at least a 1 as your rating, though a 1 will not get you very far, because if the rating is 2.5 or below, your password fails. With all of these criteria to have a password succeed, it is likely that a password will fail, which is where the generator comes in. Should the password fail, should the score be less than or equal to 2.5, the generator loop is entered. The generator loop will only break under 2 conditions. The generator is detailed here. All it does is provide a random 12-character string, as that is the default length for the generated passwords, based out of these 70 characters. These characters can be summed up as 0 through 9, the alphabet capitalized, the alphabet lowercase, and the symbols that you get when you press Shift and any number 1 through 8 on your keyboard. I've excluded parentheses from this, as I feel like it would be harder to sanitize any input if I were to allow them to be characters. The 2 conditions that would cause the while loop counter to break are whether or not the counter value, which is initialized at 0, reaches 10, which would indicate 10 consecutive failed password generations, or if the score rises above 2.5, in which case the program will display your results as detailed in the tester with a success password is and hashed password is, and give you the hashed value as well before exiting the program. I have exported this to an executable file, which I will run now to demonstrate. For my first test case, I just used the word password. and I receive the common string detected rating 0. Then it generates a new password. This one does pass as it is given a rating of 2.54, and it also outputs the hashed password. If you'll excuse me for just a moment, I have to go find that executable again. I'm going to run it with the second test case as I've just demonstrated the common bank functionality. Now I will demonstrate the repetition. And as you can see, this one also succeeds. Finally, I will give what I believe to be a good password. And it succeeds. The real trouble with something like this is that unless I were to increase the common bank to something incredibly huge, which I could do, a computer, unless you tell it, does not know the difference between a word and a random string of characters. I would in the future like to incorporate a sort of dictionary that would be able to display a number of different common words and make sure that they can't be included. One interesting thing that I did find, which builds off my last point, is that there is mathematically about a 20% fail rate on this generator. Because, like I said, the computer doesn't know the difference between a random jumble of characters and a word. So even if the password looks very complicated to us, the computer might judge it as something not necessarily that complicated. Thank you for your time.